multiplication will help you. Each base appears exactly once, so you wouldn't have like x and x in it. There are no powers of powers. Where's an example of powers of powers? Down here. This is a power of power. You wouldn't have that in your final answer. All your fractions are reduced, and there are no parentheses or negative exponents. So once you get rid of all of that, you are simplified. In the beginning, the first thing we're going to do is practice the multiplication rule, and I'm going to practice it. I don't even know why I'm in there. I'm going to practice it with these two right here. So the multiplication rule stems from something very basic, which is this. For example, if I wanted to do x to the 3 times x to the 2, x to the 3 is x times x times x, and x to the 2 is x times x, and altogether that gives me x to the 5. So the shortcut for that, so you don't have to write everything out so many times, is to just add your exponents, and that's what it's telling you right here. When it's a multiplication problem with the same base, add your exponents. So here I would have x to the 4 plus y plus 2. And I have some like terms there, so I can combine those to get x to the y plus 6. So take a moment and do 1 and 2. And if you finish those and you're like, this is super easy, move on, do some of the other ones. But we're going to do those first. So in number 1, I could write out that x 9 times, right? Because I have x to the 6, which is x times x times x times x times x times x. And I have x to the 3, which is x times x times x. But you can take that shortcut so you don't have to write it out. And you can just remember that I'm going to add my exponents, x to the 6 plus 3, which gives me x to the 9. In number 2, a lot of you guys wanted to multiply the 7 times 7, but you don't do that because we're using an exponent rule. If 7 times 7 all by itself is 49, or it's 7 squared, but it's not 49 squared because that would be doing the multiplication twice. So you keep your base 7, and your exponent is x plus 2y. And there's no like terms, so you just leave it like that. So look at your paper, and if your neighbor is not paying attention and they have something other than 7 as their base, just remind them it's not the other number, it's 7. Yes?
So like, if I see a problem like that, the strategy I use to tell you just cross out.
I missed the last part, it was a little quiet.
So like, if I'm, like a strategy I could use when I see a problem like that,
Mm-hmm.
is I just cross one of the numbers out and then just write everything.
I mean, you just use the number once. If that helps you to cross it out, that's fine. But I just remember to use it only one time as my base, and then add the exponents. And that's the way that you're including both of them with their exponents. All right, we're doing division rules. It works very similar, but when you divide, you subtract your exponents. So, for example, this one is a division problem, and I'm going to get 3 to the x minus 2, and those don't combine, so I'm just done. Okay? All right, so if you haven't done 5 and 6 yet, do those. For this one, you subtract your exponents. You have 5 minus 2, so you get x to the 3. And then for this one, I have m to the 2x plus 4, and then subtract the 3. Now, they're not all like terms, so only these two combine. So you should get m to the 2x plus 1. Okay, so you're going to work on these practice problems in a minute. But for this one, because we haven't learned the power rule yet, that's coming up. Let's consider when you square something, it means to multiply it by itself. So if I want to square y to the 3, it could be y to the 3 times y to the 3. And now it's a multiplication problem. What do you do with the exponents when you have a multiplication problem? You add them. So I would get y to the what? 6. Good. All right, try these two real quick. All right, let's look at the next one. I have the same base. Remember, don't multiply your bases. Leave it as 2. And now I need to add the exponent, but there's nothing on the second one. So what exponent should I put on it? Yeah, if anything that is not to a power, it's really to the first power. So now I can add 2x plus 1. Take a look at your work. Make sure you have that. All right, the next one is a division. So I'm going to have 6 as my base, 8x minus 1, and then you need to subtract the 2x. And then combining your like terms, I should have 6 to the 6x minus 1. Any questions on those practice problems? Okay, one more rule. Actually, it's a set of rules. And they're the power rules. If you have a power to a power, what you're going to end up doing is multiplying the exponents. And you can see it works right here, because here we had a power to a power. And if I just did 3 times 2, that would be another way to get 6. It wasn't the way we did the problem, but it would work. If you have an exponent on the outside and these two are being multiplied, you can give that exponent to both pieces, and the same with a fraction. So for example, let's do number 11. In number 11, I can put the 4 on each of these. So I'll have 2 to the 4, x, and now it's a power to a power, so I'm going to multiply 7 times 4, and I'm going to get x to the 28. And if they were both variables, I would just stop there, but because it's 2 to the 4 and that's a number answer, I can figure that out. Think for a moment what 2 to the 4 is, and then check with your neighbor and see if they agree. Here's a hint, it's not 8. 2 to the 4. What do you guys think? I have 2 votes for 16. Anybody else think 16? Yeah, good. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is going to give me 16x to the 28. All right, so go ahead and do 10 and 12. All right, so here, if you want to use the power of a power rule, you just multiply your exponents, 5 times 3, and you get m to the 15. However, another student said, well, doesn't that mean m to the 5 times m to the 5 times m to the 5? And it does. And then you can use your multiplication rule where you add the exponents and you still get m to the 15. So you should be getting m to the 15 for that one. Does anybody have a question about it? All right. This one is saying that if you have a fraction and the exponent's out here, you can apply that fraction to both parts. So it would be x to the 2 over 6 to the 2. And then 6 to the 2 is 6 squared. 6 times 6 gives us what? Good. A zero exponent. Anything to the 0 power is 1. How much is 5 to the 0?
1.
I heard one answer. I should hear more. How much is 7 to the 0? 1. How much is 5 million to the 0 power? Still 1. Okay? Anything to the 0 is 1. If you have a negative exponent, that is equal to the reciprocal. That's a tricky thing to remember. But let me give you some examples. Hey there. All right, when you have a negative exponent, it gives you the reciprocal. So for example, if I had 2/3 to the negative 1, that is going to give me the reciprocal, which is 3/2. If I had 5 to the negative 2, it's going to give me the reciprocal of 5, 1/5, but then squared. So that would be 1 over 25. So anytime you have a negative exponent, it gives you a reciprocal. And then it's going to be the positive exponent. A fraction exponent is going to give you a radical. So for example, if I had x to the 3/5, that's going to be the 5th root of x to the 3rd. All right, so here, anything to the 0, that's the easy one. Your answer is just 1. If you have a negative exponent, you take the reciprocal and make the exponent positive. And a fraction exponent is going to give you the top, the numerator gives you the exponent. The denominator is called the index. That's the number that goes in your root, like that. All right, take a chance at these three. Give them a good try, and then compare with a neighbor. Anything to the 0 power is what? 1. So your answer is just 1. All of that is being raised to the 0 power. Those parentheses hold it all together. So that's just 1. Okay? Negative exponent means we have to take the what? Starts with R. Reciprocal. 1 over x, and then your exponent is no longer negative 9, it's what? It's positive 9. This one, when you have a fraction exponent, it makes a radical. Which number goes in the index here? 6 goes here. And then which number is the exponent? 5 is good. Okay, questions? All right, so now we have some harder ones. Let's do 20 together. You guys ready to do 20? Okay.
What about 16 through 18?
Oh, well, you guys can do those. Maybe I'll do 20 and 17 with you. Let's do 17 first, and then we'll do 20. You guys ready for 17? Show me you're ready. Thanks. All right, negative numbers are fine, no big deal, but negative exponents are not. So I like to first get rid of my negative exponents by taking their reciprocal. And when you have a fraction, a negative exponent in the denominator will go to the numerator, and a negative exponent in the numerator will go to the denominator. So this fraction is going to stay the same. And actually, I'm going to make one big fraction out of it. Negative 2x squared, 3x, y to the 3. The 2 will stay up here, but the x will go down here, and the y will go up here. So notice, because they have negative exponents, they're going to switch. Anything that doesn't have an exponent, you can give it a 1 exponent just to make it a little bit easier. I'm going to pause there for a minute because I want to make sure everybody has that. You want me to read it to you, Em? It says negative 2x squared times 2y to the 1. And then it says 3x to the 1, y to the 3 times x to the 1. So I did two things. I made one fraction out of it, and anything that had a negative exponent, I moved it to the other part of the fraction to take the reciprocal. So now, negative 2 times 2, those are just numbers. I'm multiplying those to get negative 4. Negative 2 times 2 gives me negative 4. And then I have x squared y to the 1. On the bottom, I'm going to keep the 3, and I'm going to combine x to the 1 times x to the 1. And when you multiply, you add exponent, so that's going to give me what? X squared. Okay, so now let's look. Our numbers are negative 4 over 3. Does that simplify at all? Negative 4/3 is a simplified fraction. They don't have any common factors, so I'm going to leave that be. What about x squared divided by x squared? What does that do? Cancels out, right? Because it's exactly the same. So cancel that one out. And for this one, for the y's, we're going to subtract the exponents. There's two ways of going about this. I'm going to show you both and tell you which one I prefer. I could do 1 minus 3 and get y to the negative 2. That would give me a y to the negative 2 on top. And because it's a negative exponent, I would move it to the bottom and make it positive. That seems longer than my other method. My other method is to notice that I have more y's on the bottom, so start there. Do 3 minus 1, which gives me 2. And my y to the 2 will end up on the bottom. Wherever you have more y's, that's where the balance of your y's are going to go. Literally what I did right there, I'm going to look for like a sticky note or something to write on. Literally what I did right there was I had y to the 1 over y to the 3. Y to the 1 is just y, and y to the 3 is y times y times y. So those cancel, giving me y squared, and that y squared is left on the bottom. It was a question on 17. Okay, we're going to do 20 together, and then I'm going to give you some time to work on these others. All right, in 20, I'm going to start by multiplying across, and then I'm going to deal with the negative exponents after that. 12 times 2 is 24. X to the 1 times x to the negative 3, I add the exponents. Because 2 times 12 is 24. So those are just numbers, not exponents, so I really multiplied them. For the exponents, x to the 1 and x to the negative 3, when you multiply, you add your exponents, and then I still have y to the 7. That's the top. All right, on the bottom, I have 48. X squared times x squared gives me x to the 4. And I have y to the 5. I'm going to pause there because the next step is going to be work also. 24 over 48. You don't subtract them because they're not exponents. But you can simplify them. 24 over 48 simplifies to what fraction? If I can divide them both by 24, right? And this will give me 1 on the top and what on the bottom? 2. So 24 over 48 is 1/2. All right, let's look at the x's. Do I have more x's on the top or on the bottom? On the bottom. Why don't we flip what? Oh, you want to move them?
Negative exponent.
Okay, let's do it that way. There's more than one way to do it, but I agree that that's a good way to do it. So I'm going to do that. So x to the 4 times x to the 2. For the y's, though, I can subtract them, right? And so 7 minus 5 gives me y squared. You can leave this as 1y squared, but Delta Math would probably want you to make it y squared. And then on the bottom, I have 2x to the what? It's a multiplication problem, and so what do you do with the exponents? You add them to get 6. Okay. All right. I did those two. I am going to give you 5 minutes to see what you can do with these 3 problems. You don't have to get them all done, but I do want you working the whole time. Okay? 5 minutes on these 3. Okay. Let's see how we're doing with this. All right, first one, when you multiply across, I like to put the 2 first, and then I have x to the 2 times x to the 1, which gives me x to the what? Is it frozen, or no, I just in the wrong spot? X to the 2 times x to the 1 gives me x to the 3, because you're adding your exponents. Then we have y, and then over 4y to the 3. All right, then 2 over 4 simplifies to what fraction? 1/2, yes. This is the only x I have, so that's going to stay x to the 3. And do I have more y's on the top or on the bottom? I have more y's on the bottom, so I'm going to subtract 3 minus 1. That means my y's are going to end up on the bottom, y squared. Now this answer is perfectly acceptable to me, but sometimes Delta Math, instead of 1x to the 3, it just wants you to put x to the 3. And then 2y to the 2. Okay? What I think I'd like us to do